Hi there, I'm Sam, and I'm going to be talking to you about Active Radar for smart home control. Historically, when you wanted to control the items in your house, you either just did it, or you had another item to control the first item, right? I'm talking about the remote for your TV, or the other remote for the sound system for your TV, or the key to your door. Smartphones have come along and done a really good job of consolidating a lot of that control power into a single device. And that's great until maybe you lose your smartphone, or if you're in the kitchen and your hands are dirty and you want to set a timer, right? To alleviate this, we have sort of two routes. We have voice control, or we have gesture control. Now, gesture control is really nice. It's super convenient and very versatile because it takes away even that one controller and puts you in control in a way that you'll never lose or not be able to access. But it does have some drawbacks. Constantly being watched by cameras might make you uncomfortable or raise privacy concerns, and it's difficult to design gesture control systems well for a few reasons, including that they have low discoverability, meaning that it's hard to figure out what you can do with them just by using them, and you're not getting enough feedback while you're doing those things, so you're not even really sure if what you're doing is working. Another big design challenge when you're making a gesture control interface is that gestures are very contextual, right? If a user raises their hand up, that might mean one thing when they're watching TV, they want the volume higher, or it might mean another thing, like the thermostat needs to go up, right? So how do you disambiguate there? Well, one option to disambiguate between items is called path sync, right? Path sync is where if you have a bunch of menu options, like this guy does, it draws beads around each one, moving at different speeds and in different directions. And then the user tries to sync his hand movement up with the bead that's going around the menu option he wants to select. Well, you can do that in the real world too, by just putting an LED outline around each device you might want to control, and then just doing path sync. This is great because it improves your discoverability a little bit, right? Now the things that you can interact with literally light up in the real world so that it's super easy to see your options. It's easy to disambiguate between devices so that that hand-raising gesture can now be matched to the device it was intended for. And that LED ring can be really good for giving users instant feedback, right? You're getting feedback while you're selecting the device, but then you can also maybe pulse the LEDs while, say, the device is connecting to the internet, so that the user knows that what he's trying to do is in the works. However, there are problems with the original path sync, which are mainly related to the fact that our camera that you see here, right? Constantly being watched, especially by a big sort of ugly camera, isn't very pleasant for anyone. And it's especially unpleasant in a space that's supposed to be intimate and cozy, like your house, right? It's also maybe not the best aesthetic thing for your house, and it can make you feel uncomfortable because you sort of start to wonder if your privacy is being violated by this camera. Plus, if you want to be using gestures anywhere in your house, or even at a variety of angles, you're going to start to need multiple cameras, which just compounds all of the problems that I was talking about. So the solution we've chosen for this is Radar, right? And we're using this little board right here. Now, Radar has a number of great advantages. It works through bodies and even through walls at certain frequencies, so that you don't need a lot of radar antenna to be very effective in capturing user gestures. It physically can't distinguish between individuals because all it's really doing is ranging and gauging velocity. So you can't really get an idea of who someone is, which is a built-in way to alleviate a lot of privacy concern. And on top of that, it doesn't look like a camera, right? It just looks like a little board. You can put this in a case mounted on your wall. It's very, very discreet. And so that's great. It really ups that comfort factor and allows you to sort of reclaim a space as your own. So to see if this radar would actually work for what we wanted to do, our team conducted a Wizard of Oz study. Basically, we had one person perform gestures by trying to move their hands in these shapes. These arrows just mean moving your hand up and down. And then someone else tried to interpret what they meant by matching each one of these shapes to a digit. In our results, we were very encouraged because we got 87 out of 90 correct. In 2 cases, the person who was trying to interpret the gestures missed one. And in 1 case, the person who was trying to perform the gestures got a little confused between these 2 triangles and actually messed up the signal that they were sending. So in total, that 3 out of 90 dropped our accuracy from 100% to almost 97%, which is still incredibly high. So we were ready to dive into a solution.
The intended gestures we want the user to perform is to have their hand moving within no geometric shapes. Since the radar detection is much easier to detect displacements and movement speeds, but could cause possible lag when detecting the exact position of an object. And for the user interface, we want to have 2 to 4 different types of moving patterns shown on the screen, and ask the user to make selection between them and mimic one of the moving pattern based on the screen. And so it will be represented by the line showing the trail of the path and the single dot showing the movement of the object. And we want to study whether hand gestures radar detection can be used to detect hand gestures with fair amounts of accuracy if the object is moving with different speeds and along different shapes.
Hello everyone, my name is Davina Woolley and I will be discussing how the Active Radar team will be conducting in-person user studies during November of 2020. So we are planning on conducting in-person user studies either on the first floor of the Kolk building or on Tech Green. The safety of our participants and our team members are our utmost priority, so we will be requiring all individuals present to wear masks, and we will be providing gloves. Both will be required, and the gloves are really just for an additional safety precaution. So if you are interested in participating in our study, the first thing we would ask you to do is to schedule a time for your user study. And upon arrival, you will be asked to scan a QR code, which will serve as your digital sign-in, and you will be asked to complete a participant consent form. You will be instructed to watch an instructional video, which will teach you how to interact with the Active Radar system. You will then just have to answer a simple question: did you watch this video? And just state yes. And then it will be time for your study, and you will be asked to complete a series of tasks. And our team will collect various information about your interaction, ranging from qualitative data to quantitative data. And we will just be answering questions such as how long did it take a user to accomplish a certain task, what did we perceive their user frustrations to be, and commonly made mistakes made by the user. Upon completion of your user study, you will then be asked to scan a final QR code, and this will serve as your final reflection form, which will also be made available through Qualtrics. And you'll just state what your overall opinion of the technology was, notes about usability, what you had difficulty with, and then that will conclude your user study. Our team will then analyze the data collected, and we will use that to assist us in determining the next steps. Our goal with our device is to effectively alleviate the need for any physical input devices needed for interacting with your technologies.